Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Chapter 3.5, credit cards. How's everybody today? Here we go. Credit cards. Most people have them. Most people abuse them. Most people pay way more than they should for products because of them. All right, so anyway, here we go. Objective, define the basic vocabulary of credit cards, and we're going to compute an average daily balance. All right, so let's do the vocab first. What is a credit card? Back in the 1950s, credit cards were created. They are a plastic card that entitles the holder to make purchases and pay for them later. So there's a monthly interest rate. A credit card, you can carry a balance. You pay interest on it. So that's a credit card. Impulse buying means that you want to purchase something which you suddenly were attracted to and had no intention of buying. Impulse products are usually put near the registers in stores to make it look like, oh, you need this while you're waiting in line. Okay, so that's impulse buying. Okay, impulse buying. And usually the products there are more expensive than in a bulk package back on the shelves somewhere in the store. So they charge you more. All right, so revolving charge account. What is a revolving charge account? This means that the entire bill, okay, so there are two types of credit card accounts. One being the revolving charge account, which means the entire bill does not have to be paid in full each month. So if I charge $2,000 on my credit card this month and only paid $1,000 on it at the end of the month, I'd pay interest on the remaining $1,000. And I could still make purchases because there's a credit limit. So if you didn't meet your limit, you can keep charging. So that is a revolving charge account. A charge card's a little different than a credit card. Charge cards are like, American Express used to always be a charge card. They do now have credit cards where you can carry a balance, but initially they were charge cards. What does that mean? Well, let's say I had an American Express card with a $1,000 credit limit and I charged $900 on it this month. I have to pay that $900 at the end of the month, or there's a hefty late fee plus interest. So in order to avoid the interest and late fee, you pay it off at the end of the month. That's a charge card. Charge now, pay at the end of the month, no remaining balance. All right, Truth-In-Lending Act. The Truth-In-Lending Act protects you if your card is lost or stolen. Okay, if you report it lost or stolen before anyone uses it, you are not responsible for any charges after that point. If you have your card lost or stolen and you don't report it missing and someone uses it, the Truth-In-Lending Act will protect you from having to pay the entire amount, and they will limit it to $50. Okay, and then we have what is called a Schumer Box. So let me bring one in to show you what that looks like. Okay, so here's an example from the book that looks like it's a Schumer Box. There's more to it as well. There's penalty fee information, there's transaction fee information, there's annual membership fee information, and it tells you, now the new ones tell you how much you would have to pay in total if you only paid the minimum every month. That's a new law. So if you only pay the minimum, it will take you this many months to pay and you'll have paid this much. They tell you that now. All right, so that is the Schumer Box. It's named after Chuck Schumer, who was a senator who he sponsored the legislation on this being put on credit card statements. All right, so Fair Credit Billing Act protects you if there are any errors in your monthly statement. So if you charge $1,000 and there's an error in your statement, and they say you owe them $1,100 and they charge you interest on the $1,100, you're paying interest on $100 more than you should be. The Fair Credit Billing Act will protect you, and they'll be like, okay, no, you have to go back and make these corrections, and you owe me my interest I paid on that wrong balance, and I want that money back. So the Fair Credit Billing Act gets you that protection. All right, the Fair Debit Collection Practice Act prohibits a creditor from harassing you or using unfair means to collect the amount owed. Okay, so if I charge something on my card and I don't pay it, a guy can't call me up and say, if you do not pay this, I am going to break your kneecaps. Or it used to really happen. I remember back in the late 80s, early 90s, people I worked with would get phone calls with harassing, threatening things on them and their families. And that now is protected by the Fair Debit Collection Practice Act. Okay, they did used to do that, call and harass. Okay, so now they can't. All right, debit card is similar to a credit card, except it's connected to your checking account. And a debit card you cannot use unless there's money to back it in your account. So if I have $1,000 in my checking account, I can use my debit card up to that amount. I cannot be overdrawn. It's like writing a check that you can't cash. Okay, there's no money to back it. You cannot use a debit card if there's no money in your account. Okay, debit card. Electronic Funds Transfer Act protects debit card users against unauthorized use in their cards. They're not responsible for purchases made with a lost or stolen card after the card is reported missing. Okay. All right. So that's that. The Electronic Funds Transfer Act protects debit cards, much like the Truth-In-LendingAct protects credit and charge cards. Okay, and the average daily balance. Well, if you have an annual percentage rate, the average daily balance is just that. You take the average of how much you owed in interest throughout a month, divided by how many days are in that month, be it 28, 29 in a leap year, 30 or 31, and you come up with your average daily balance. And we will do a problem like that in this lesson. So let's get to it. Okay, example 1. Frank lost his credit card in a local mall. He notified his creditors before the card was used. However, later in the day, someone found the card and they charged $700 worth of hockey equipment on it. How much is Frank responsible for paying? Okay, that's a really simple answer, because if you were paying attention to the vocabulary, the truth in lending act protects card owners from being charged for lost or stolen items or credit cards when items are charged to it. So if he reported it before the card was used, he owes $0. Okay. All right, so now let's do the check your understanding. Carrie had her credit card stolen. She didn't realize it for days. Sometimes, it's in your wallet, you never use it, you don't look at it. Then you go to use it and it's not there. That's usually when you decide something's wrong. Uh-oh. So at which point she notified her creditor. So she did notify her creditor when she realized it was not in her possession. So during that time, someone charged $2,000. Okay. But she didn't report it. But the Truth-In-Lending Act protects her, and instead of having to pay the $2,000, she would have to pay $50. So what happens to the other $1,950? Well, the credit card company's got to take it on the chin, but if they catch the person who used the card, the credit card company would go after them in a court of law and try to get their money back. Okay, example 2. Credit card companies issue a monthly statement. Therefore, APR, annual percentage rate, must be converted to a monthly periodic rate. If the APR is 21.6%, what is the monthly finance charge? So this is really simple. All you do is take the 21.6% interest rate and divide it by the number of months in a year. And when I take 21.6 and divide it by 12, I got 1.8% monthly finance charge. Okay, if a monthly statement shows a monthly interest, if a monthly statement shows a monthly interest rate of X percent, monthly interest rate of X percent. I'm going to set this up just like this here. Put an X there. Equals. Express the APR algebraically. Annual percentage rate is my numerator. I'm going to call it A for APR, divided by 12. Okay. It wants to express the APR algebraically. So I want to solve for A. So I'm going to multiply both sides by 12. And that is going to give me A equals 12x. Okay. So there it is. Algebraic expression or equation, actually. Okay. Example 3. Rebecca did not pay last month's credit card bill in full. Below is a list of her daily balances for her last billing cycle. Okay, so 7. So the first thing you want to do is, it says to find Rebecca's average daily balance, by the way. First thing you want to do is add how many days up there is, and then that's how many days are in this month. 7 plus 3 is 10, plus 6 is 16, plus 9 is 25, plus 5 is 30 days. So there's 30 days in this month. So it's 30 days, has September, April, June, and November. So it's one of those months. Okay, the next thing we're going to do is take the number of days times the amount that was owed for those days. So I'm going to take 456.11 times 7, 3 times 1,177.60, 6 times 990.08, and then 9 times $2,115.15, and then 5 $2,309.13. Okay, so obviously on day, so for 7 days she owed this, and then on the 7th day she charged more to bring it from 456 to 1,177, and then 3 days later she charged more, and then 6 days later she charged more, and 9 days later she charged more, and that was the remaining of her 5 days, and then she didn't charge anymore. That's what has happened here. So she's made 5 different purchases and increased her bill. So now we're going to take the calculator and we're going to solve this. So it's 7 times 456.11, and that is 3192.77. Okay, and then we're going to do 3 times $1,177.60, and that is 3532.80. Okay, and we just keep doing this. And 6 times 990.08, enter, and that's 5940.48. And then we're going to take 9 times $2,115.15, and that is 19,036.35. And then finally 5 times 2309.13, enter, and that's 11,545.65. Okay, so once I do that, I'm going to take them and add those all up. Okay, and in adding all those up, just to save time, I'll just do it here. It's 43,248.05. Okay, and then we take that amount and divide by the number of days. So we're going to divide this by 30, and that is going to give us, let's just do it, 43,248.05 divided by 30. That comes out to be 1,441.60. Okay, so that was her average daily balance. So then they would take that and multiply by the interest rate for that month. Okay, so now it says check your understanding. Last month, Paul had a daily balance of X dollars for 6 days. So we're just doing this here. So it's going to be 6 times X. Let me just not use parentheses because it's just a variable and a coefficient. So it's 6X. And what do? We just added all of these up. So this was 7 times this was 3 times that, and 6 times that. So this is my X, and it says it says X dollars for 6 days, Y dollars for 12 days. So I'd be like this one here. So we're just naming these different dollar values with variables. So 6x, and we add them all, y dollars for 12 days, should put the coefficient first, it's 12y, plus w dollars for q days, so that'd be q days times w, and d dollars for 2 days, 2 times d. Express the average daily balance algebraically. So we take that and we divide it by, now be careful, we don't know how many days this is, we don't know how many months are in the day, I'm sorry, how many months are in the, how many days are in the month. So what we do is we add our coefficients all up. So it's going to be q plus 6 plus 12 is 18 plus 2 is 20. So it's going to be q plus 20. We don't know what q is. So q could be 8, 9, 10, or 11, depending on which month we're talking about. There is the expression. Okay, example 4, last example in this chapter. Rebecca from example 3 pays a finance charge on her average daily balance of $1,441.60, which is what we just calculated. Her APR is 18%. What is her finance charge for this billing cycle? So we need a formula. There is a formula. Okay, so this is it. Finance charge equals the monthly rate divided by 100 times the average daily balance. Okay, because it's percent divided by 100. All right, so here's what we're going to do. We want to take and 18% divided by the number of months in a year is 1.5. That reduces to 3 halves, 1.5. So the finance charge is going to equal 1.5 divided by 100 times the average daily balance, which is 1,441.60. Okay, and that is going to equal 1.5 divided by 100, whoops, divided by, not close parentheses, divided by 100, 1.5 divided by 100 times 1441.60, enter, and it's $21.62. Okay, so there's the finance charge for that month. So now it says Steve owes a finance charge this month because he didn't pay his bill in full last month. His average daily balance is $D. And his APR is P%. Express his finance charge algebraically. Okay, his average daily balance is, so the average daily balance is what we're multiplying by, is $D. So it's D, and there's going to be 100 over, or something over 100 times that D. And it says his average daily balance $D and his APR is P%. His annual percentage rate is P%. So we have to take that P%, which is up here. So let's think about this a second. Okay, P%, 0.01 is what they're saying. Okay, so I'm just going to do this the way we did it up here. So the book is showing it differently. The D is outside the parentheses. The 100 would be in the denominator, but how did I get this 1.5 up here? Well, it was the APR divided by 12, and APR is P%. So it would be P divided by 12 divided by 100. Okay. But if I take P over 12 and divide that by 100, think of it as over 1. Remember the rule from 7th grade or 6th grade, you take the numerator and leave it alone, and you take the denominator and multiply by its reciprocal, okay? And you're going to get P over 1200, or I could say 0.01 p over 12. Okay, because 0.01 is 1/100th, and if I divide both by 100, or then it'd be 1/100th, 10/100th, 1/100th of p divided by 12. And that's how the book shows it. So it could be p over 12 divided by 100 times d, or you could say 0.01 p over 12 times. Okay, those would be two possible solutions. And that's the end of lesson or chapter 3.5. Okay, have a good day and thanks for watching.